Hello everyone, welcome to Kotlin Mumbai. I hope everyone is enjoying their weekend and this is on Saturday. And again, we are back with a virtual event because it's good to be online because we can have speakers across the globe. So that's the reason we are still keeping it virtually. And today we are going to have an amazing session from a speaker who is from itself from JetBrains. To make this event more better, and on the Saturday evening. So that's the reason we have brought such amazing speaker. Before that we start, we would like to just introduce about ourselves, who we are exactly. So we are an open community for developers. We love stuff related to Kotlin, and that's our main focus. So we just keep bringing talks related to Kotlin, and we also do talks related to Android as well, specifically to Android app development. So for more information, you can visit our website kotlinmumbai.org, which is our official website for the community. And for staying out for the latest updates and new events and sessions, you can just stay tuned on our Twitter handle, which is Kotlin Mumbai. And we are also present on different social media platform as well. You can find the links on the screen for now. So that was a little introduction about the Kotlin Mumbai community. Since we are going to attend this event, so we should be having everyone at sync, and there shouldn't be anything miscommunication or anything happening bad. So that's the reason we have to like to introduce about the code of conduct. For that, I will hand it over to the Shreyas.
So, hey everyone, have a great weekend, and it's very good to see you all back for another session at Kotlin Mumbai. So, before we get started, we are here to enjoy talk and let others enjoy it as well. So, do visit our website kotlinmumbai.org to know more about our code of conduct. Now, I will hand it over to Rishi so that he can let us know more about our today's speaker.
A bit of mute, I suppose.
Oh, mute. Okay. I still haven't acclimatized to that. Okay. So today we are joined with Leonid. Am I pronouncing your name right?
Yeah, all right.
And he works on the Kotlin Libraries team at JetBrains, and he has worked there for more than 4 years on projects like kotlinx.serialization. And he loves to discuss code evolution, compatibility, and other things related to readable and maintainable code. I'd also suggest you take a look at his Kotlin X serialization talks. Those are a real pleasure to watch. And now I'll hand it all over to Leonard. And feel free to share your screen.
Yeah, thank you for a kind introduction. One moment. Yeah. Okay, let's go. So yes, the screen is okay, I suppose.
Yep.
So we are okay. So we are going to talk today about undercover, so-called, or just simply dig into a bit into modern coverage tools. So yeah, so yeah, this is about me slide, but I was already introduced. So basically, if you want to reach me out on Twitter or Telegram, you can find me by this handle, Sandrace. And let's continue. So let's first remember ourselves a bit what is code coverage. So assume we have this main class that consists of three functions. Hello world function returns hello and call other function. The greet function that returns hello and the string argument it was passed to, and the world function that is simply a string literal. So if we write a test for this class, first we instantiate this main class, call a constructor, and then we write a simple assertion that m.greet from m.world contains our world word. So the question we should ask ourselves is, have we tested all these functions? So we know that we called greet and world function, but if we look closely, we can find out that we forgot to call the very first function, whole world. And Thus, it can contain some bugs or some incorrect implementations that we haven't thoroughly tested. So basically, to save us from these problems, there are cut coverage tools. Coverage tool is a tool that just shows you which lines of your code have been executed during the test run. So we can solve the following problems with these tools. Coverage tracks, as I said, functionality that hasn't been thoroughly tested. Also, it helps you to track edge cases or dead code that haven't been executed. However, the coverage tool doesn't help you with writing a correct test or catching bugs, so it still is up to you. It just shows you which code path you haven't tested. So this was a brief reminder from my previous talk. But today we are going to talk about how coverage tools work and how they're related to the Java agents. Then we are going to talk about what the difference between coverage agent and the rest of the tool. And at the last part of the talk, we would discuss the cover itself and why does one need cover and how this new tool works. So let's start with Java agents. So basically, Java agent is just a Java jar with some classes that are packed and loaded in a certain special way. Java agent is different from a regular Java program because it has an access to the instrumentation API. The instrumentation API is a part of Java runtime environment itself. Instrumentation API is a special thing that allows to modify the classes bytecode for classes that are loaded into the very same running JVM. So it is done without recompiling. If you would want to write your own Java agent, it would roughly look like look in the following way. So instead of public static void main, we have special agent main function that additionally accepts some instrumentation parameter. Basically, this instrumentation parameter is an entry point to everything you can do. For example, you can add some transformer uh, to the current JVM and then retransform some classes using this transformer. You can transform particular classes, like in the example we load a certain class, or you can transform all classes in the running program. So there are actually a lot of appliances for Java agents. They are used for example, for profiling, for aspect-oriented programming, for mutation testing, and so on. And they're also used for collecting coverage. How is this possible? Let's take a look at this simple example. We now have public final string goodbye that accepts another string s. And this function is very simple. We just check that if s length is equals to 0, then we return simply goodbye string. And if its length not equals to 0, we return goodbye plus s and plus exclamation mark. So now if we transform this function with a coverage agent, we take, for example, the JCoco, one of the most popular Java coverage tools. We can see that after transformation, there are new additional statements in our function body. So we have a new statement called JCoco init. It's a special function from JCoco runtime that returns a certain array for us, a Boolean array. And then we see that our ternary operator is split into proper if-else branches. And in each branch, there is a certain assignment to the array. So we can see that in the first branch, we assign an array element under index 7. And in the else branch, we are assigning an element under index 8. Looking at this transformed class, it is relatively easy to figure by ourselves how coverage tools work. They just put up additional statements in our code, and then looking at this array, for example, we can judge which statements or lines of code have been executed. Indeed, if this array contains true at the position 7, we can conclude that the first if branch was executed. If it wasn't, then it means this branch wasn't executed. Just add a special array assignment before each line, and we can check whether and what lines have been executed during a test run, a very definition of the coverage tool. Now we can came to the following conclusion that instrumentation API transforms classes bytecode. It also means that instrumentation API doesn't have any any means to manipulate bytecode itself. You need to resort to the other libraries like org.objectweb.asm, so on. But for us, it is important that it works with already compiled Java files. And we can conclude that we actually can use the very same tools with Kotlin code, because Kotlin compiler produces the very same bytecode for running on JVM. So if we transform bytecode, it doesn't matter whether it was produced by Java or by Kotlin compiler. In general, of course, there are some nuances to that. So now we have understood that core of the coverage tool is an coverage Java agent. But is it all in the tool or not? So let's take a look at how Java we can attach a Java agent to our program. It's relatively simple. We just pick the usual Java command line command, and we add to it one argument, -agent, with our agent jar. Then we can continue as usual. So we specify our application.jar and pass certain args to it, whatever it needs. It's indeed simple. We need to only add one new argument. But let's take a moment and remember last time any one of you has invoked Java command manually. Probably it wasn't today and it wasn't yesterday, probably not even this week or this month, because we live in a modern world, and the modern world has tooling, and most tasks like compiling the code, packaging jars, launching, running tests, and many more are handled not by manually but by build systems. For example, Maven, Gradle, and name whatever you use. So it may not be convenient to work with agents manually. Additionally, we after we collected some coverage, get this Boolean array or whatever, we also may want to display results somehow nicely. For example, JKCore can generate us nice looking HTML web page with table with counters. And besides getting and displaying results, we may want to assess them. For example, to verify that we have enough lines covered in our program, which coverage tool also can do. And so we can conclude that most tools are actually bigger than just an agent. If we take a look on the aforementioned JKCore, we can, of course, find an agent there in the list of the jars. But we can also find a Maven plugin. We can also find a command line interface. We have some cores, some reporter functionality, and tasks, and so on and so forth. Actually, we may not get a look at the agent at all, because let's take, for example, the IntelliJ coverage tool. if you didn't know, IntelliJ have nice coverage functionality. You just need to click one button called run with coverage, and it will run your tests, collect the coverage, and display it in the nice table, nice tool window directly inside the IDE. And it also cover the lines directly in your source code in the editor. In this scenario, we didn't even know if there is an agent, but I can tell you that yes, there is an agent. It is a specific IntelliJ IDE agent that is written inside it. But for us, for users, it is completely invisible because we have buttons, we have nice UI, so on. So problem with this approach is that different tools are not very interchangeable and they are not friendly to each other. Indeed, we can't use a JCACO agent and an IntelliJ report UI. We can't use IntelliJ agent and JCACO verifier. And for example, IntelliJ agent doesn't have any Gradle plugins at all. It's just the UI. You can't even pick it out of India. So to mitigate all these problems, we created Kover, a new Kotlin code coverage tool. Let's take a closer look at it. So to understand Kover, it is important to remember that Kover is just a Gradle plugin and not an coverage agent. So we can include it in our project like a regular plugin. And there is no coverage agent. Instead, as a Gradle plugin, Kover works with multiple coverage agents. So currently there are available 2 agents, which are also called engines. So we can either choose either to work with IntelliJ coverage or with JCACO coverage, whatever your needs, whatever your needs are. And to be able to freely switch between these agents, Kover provides a certain level of abstraction over common tasks. Example, we have Kover report task, which includes XML and HTML report, and Kover verify task, which we will take a look into a bit later. So if we take a look at how Kover report task works with JCACO engine, it can be displayed as following scheme. So user invokes Kover report Gradle task. Because JCACO have its own task that invokes reporter, we can simply delegate to it and say, hey, this is class path, here is your class path, build your report. Then we just can put the results in the specified folder under build/reports. Simple and convenient. However, if we want to use an IntelliJ agent engine, it is a bit more complex inside. So user invokes same Kover report Gradle task, and Kover inside makes some preparations because the API of JCACO and IntelliJ engines is, of course, very different to each other. So we first need to do some preparation, create temporary files, make an arguments list in JSON and so on. So then we can execute reporter directly, this time with Java exec, with basically invoking just simple Java command instead of delegating to some existing task. But in the end, we would get a same result in the same folder because Kover handles it for us. So all this hassle of how to launch different engines and how to get results for them from them is abstracted away. For user, API looks very straightforward. We invoke Kover task and we get the result. Very easy. And this is the whole intention of Kover, to abstract away hassle of communicating with different engines. It also saves you from writing different settings, because settings also stay the same. Let's take a look at the filtering. Filtering is a very important feature that allows us to include or exclude some packages of our application from coverage collecting if we don't care about them, or there's some utility generated stuff or something. Filtering in Cover is performed by configuring a certain extension on existing test tasks. So we just need to call extensions configure cover task extension and provide some includes and excludes list. And this configuration, this setting line would work the same regardlessly of what coverage engine you have chosen, because that's the very purpose of Cover. So we, sorry. Cover also offers you verification. Let's talk about it a bit more. So imagine we have a certain quality criteria that we can express in certain coverage levels. So let's say, for example, that our quality criteria is that our code base should have a 75% of its lines covered. And if it doesn't have so much lines covered, then it doesn't meet our quality standards and it shouldn't be released or ever built. So basically, Core Verify task checks it automatically for you, and it would fail your build if it doesn't meet certain criteria. The criteria are set up in the following manner. So we have just to configure Cover Verify task and write some rules in them in it, and they would work again no matter what engine you've chosen. So rules may or may not have a name and should have one or more bounds. So bound is basically a minimum or maximum value. In our example, it is min value 75. And a value type. In our example, it is covered lines percentage. So this following this configuration would fail your build if the percentage of covered lines is less than 75. Very simple. Let's take a bit. Let's take a small look at verification types. So we have currently 3 verification value types. It's covered lines count, missed lines count, and covered lines percentage. The default one is covered lines percentage. So in most cases, you don't even need to specify the value type in the bound. Unfortunately, due to the fact that we are working with multiple agents, we can't provide all possible counters. For example, Jackacore offers certain advanced counters like branch counters, which count how many branches we hit. But since the IntelliJ IDEA agent does not provide such counters, neither can we provide them. So we currently are narrowed down to only line counters, covered or missed, but in the future we aim to remove this limitation. Another important feature of Cover is the collection of merged tasks. So to understand why we need them, let's consider the following structure of Gradle projects. So we have some Gradle root project, and we would have 2 sub-projects in it. So first of them is, let's call it API, and it has some source. And the second one is an implementation, which also, of course, has source files and also test files. And basically, the all testing is performed in the implementation Gradle project. The problem is the following. If we will treat this project separately, then what happens? when we collect the coverage for the API project, it is equal to 0 because there are no tests in API project, and therefore we haven't covered anything. If we collect coverage only for implementation project, then we would cover only the source set of the same implementation project. But and even though if it uses some decorations, some maybe helper functions, some delegations from the source set of API, we still can't verify that we covered them because they're in the different module, in the different project. And currently we collect coverage only from the implementation project, not have API. So the problem is that test source set covers actually 2 Gradle projects instead of 1. And we need to treat these sources, API, SRC, and implementation SRC, as one, despite they're located in different modules. So to do that, there are certain tasks in Kover that are called Kover merged. So we have also Kover merge reports, the same as to Kover reports, the Kover merge verify, and also Kover collect reports. What they do, they collect first coverage from one project, then from second project, and they merge them together. So all the sources are treated as one, and we can give an aggregated report on whether certain functions or classes were tested and covered, regardless of where the actually source set of them are located. It is a very useful feature. For example, in Kotlin serialization, there is Kotlin serialization core module and Kotlin serialization JSON. And testing of the core of various serializers is happens very much in the JSON module because, well, core does not have the format itself, so we can't serialize into anything. So if I would test the core, I combine reports from the core and the JSON together, I get I can see that most of the declarations, if in these 2 modules, are covered. It is also very handy even in more complex scenarios like multi-platform projects. So typical multi-platform project looks like this. We have again Gradle root, some JVM specific module, for example, server app with sources and test. And we also have some common project, common module, which have a lot more source sets. For example, common main, JVM main, common test, JVM test, and so on. So again, if we would even use some kind of existing Gradle plugin, for example, Jackeco, we would need to manually set all this configuration because JKK doesn't know about common main, JVM test, and all the source sets are very specific to Kotlin. But Kover automatically handles MPP projects for you. It can understand that common main and JVM main are actually being tested at once on the JVM because they emerged on the when we run test for the JVM. And using Kover merged report, we can combine all these 2 projects together to get collected report, merged report for them. However, we should remember that all tests executed on JVM would be instrumented for coverage, but since we use JVM agents, Java agents, we do not collect coverage for JS test or native tests at all. So to sum things up, the Kover lets you first choose between 2 agents, whatever suits your needs most. Yeah, let's remember that JKK currently doesn't handle inline Kotlin functions very well, so I would recommend the IntelliJ agent. So then you can set up filtering and verification rules as in any other modern coverage tool. Then it also automatically handles multi-platform projects for you. And then it also handles report merging, which is very useful if you have complex multi-project, multi-module structure. So if you want to try Kover, you can simply put it as a plugin to your build script. If you use Gradle Kotlin DSL, you need to just put id org.jetbrains.kotlinx.cover into your plugins block. So the last actual version, last released version for now is 0.5. And if you use Gradle Groovy DSL, basically it's all the same ID, same version, just a bit different syntax. All the documentation and the latest releases are available on our GitHub repository. There's big README with description of how of what each task does and where it is invoked, with examples both on Kotlin Gradle DSL and Groovy Gradle DSL. So I hope you've enjoyed my task. Thank you my talk. Thank you everyone for coming. And now I'm here to answer. I'm ready to answer your questions.
So that was a really exciting talk, and I learned quite a lot. So I'll get the questions up. We have a couple of questions. Um, I'll just get them up on your screen, and then you can start answering them. Okay, so we have quite a few questions, and you'll also see those questions on your screen. The first
Okay.
one we have is, does Cover support Android instrumentation or UI test coverage and merge them with unit test?
Okay. So currently, as far as I remember, we do not merge Android instrumentation separate Android plugin for Android, because Android projects are made a bit differently. So as you know, they have flavors, release flavor, debug flavor, and so on. And the whole Android plugin is very different from regular GVM plugin or Kotlin plugin. So we need to be able to communicate with it. To be able to retrieve all this information about flavors, about source set, and so on. This is one of our tasks in priority. So we expect to be fully capable of handling Android projects with all flavors and tests and so on in, I believe, in a few months.
Wow, that's interesting to hear. And I'll definitely, and I think all of us would definitely love to try it for our Android projects as well. Uh, the next one is, does it support offline instrumentation just like JCocker?
Okay, no, we do not have it yet, but since we got some issues again regarding that some instrumentations are not combined with other instrumentations, we may want to consider adding offline instrumentation too.
The next one is, does Core work out of the box with composite builds?
That's an interesting one. I don't know. Actually, I've never tried, and I believe no one on the team tried that. But well, technically there shouldn't be problems, because as far as I remember, composite builds in Gradle are um, made that way that included build is just another project. So it's worth trying.
Yes, this would be a fun exercise. Uh, the next one is again about an Android project. So I'll skip this,
Mhm.
I think. Um,
And then, yeah, the advantage was that, for example, JCoco that doesn't handle inline functions correctly, and there are also, as far as I believe, certain quirks about using JCoco with Kotlin. So, bit about integrating Cover with SonarQube. Uh, well, that's I believe should be simple because the when you use it with Jacaco engine, you get a regular Jacaco report, and when you use it with IntelliJ agent, you get basically also a very same report with the same format. We try to make those reports as much uh, close to each other as possible. It should be down to just points on our cube where to the folder where this the cover report resides, and it should be all.
but the next one is about a very big issue with Jacobo was not being able to exclude a couple of specific annotated functions. Could you do so with Kover?
Uh, oh, there's no such functionality in Cover itself, but I believe IntelliJ agent can exclude these functions. And as far as I remember, we have a plan of adding certain of adding a setting so one can pass an array in the Gradle script and list the annotations that should be excluded.
But is there code curve integration with Kover?
Yeah, I think it's the same with the Sonar Cube. You just point codecov to the place where cover report resides. And because it is very similar in structure to JCoco report, it should be parsed with existing tools.
But the next one is, does it work with a code base having a mixture of Java and Kotlin sources?
Yeah, yes, I believe it should work because both agents can work with such sources.
The next one is about one of the code demos you showed in your slides. You showed an example of line coverage. Is it possible to add rules for classes and functions?
Mm, well, if it is a question about verification about counters, as I said, we currently support only line counters, so no rules for classes and functions for now.
The last question we have is, are there any current limitations of Kover over Jacobo which can block us from migrating to Kover?
Well, as I said, Cover uses JCoco, may use JCoco agent internally, so I believe migrating should be straightforward if you don't use, I don't know, cyclomatic complexity counters, for example. The filtering, the emerging reports is all there, and you still can use JCoco agent if you have some speciality in it.
Got it. So those were all the questions we had for the day. And thank you again, Leonard. It was really fun to hear your talk. For all the others, if you want to listen back to something, see some code back, we'll also publish a recording of this on YouTube. And Siddhesh, should you like to go on?
Yeah, hey, am I audible?
Yes.
Perfect. Leonid, thanks for attending our community and giving this wonderful talk. We had some really nice insights. And looking back at this presentation, I think everybody who's trying to migrate from something like Jacoco or discover Cover, they will have great insights from this presentation we've had. And we'll also be publishing this, like Rishit said, on our YouTube channel, so people can revisit this meetup again. So thanks, Leonid, for being a part of the community and showcasing this wonderful presentation and new tool.
Thank you for the invite. I liked it.